Hello friends, here in this video we will see what is meant by fatigue failure. It is fatigue failure. Now, first of all, to understand fatigue failure, we should know one concept, and that concept is of reversed or cyclic stresses. So I'll come back to fatigue failure once we can understand what is the meaning of reversed or cyclic stresses. So for this purpose, suppose we have a beam. Now this beam is supported at two ends. Next, capital L is the length of this beam. Now suppose a load is acting at the center of this beam. Now if I look at the cross section of the beam, I am assuming that the beam is of circular cross section. Now I'll note 2 points on this beam. I'll say that at the top here I have point number A, at the bottom I have point B. Now my assumption is that this beam is circular and at the same time it is rotating. That is, we provide rotation to this circular beam. So here I'll say that let there be a circular beam of length capital L rotating on two supports. So here in the diagram, as I can see, the beam is supported at two ends and we are considering that it is rotating. Now because of this load, since the beam is rotating and at the same time there is load acting over this, so what happens? Suppose at first instant the load is acting at point 1, or we can say point number A. Now if A is at the top, I can say this top layer is A, bottom layer is B. Then when load is acting, the top layer of the beam will be compressed because of the load, whereas the bottom layer, it will be in tension, it will be elongated. That is if point number A is at the top. So I can say that when point A is up, then compressive stress will act at the topmost layer. So as I can say that when this load is acting at the topmost layer, there will be compressive stress. Or I can say when point B is downwards, then B would be subjected to tension, because we know the bending pattern of a simply supported beam. Here I have simply supported beam, it will bend in this way. Here I am drawing the diagram and indicating it will be bending in such a way. So in this way this simply supported beam will bend. So as I can see, the top layer is subjected to compression and the bottom layer, that is at point B, since it is downwards, then tensile stress will act at bottom. layer. So here it is clear that when the load is acting and point A is up, A which is the topmost layer, it will be subjected to compressive stress, and the bottommost layer, that is layer B, it would be subjected to tensile stress. That is when point A is up. Now take an example that this shaft is rotating. So in next turn what happens? Instead of A, point number B goes up. That is B becomes the upper layer. So now if I say that for the second case, when the shaft will rotate, then point B will reach up, whereas point A will be at the bottom. So now the action is reversed. Previously A was subjected to compression and B was in tension. Now since point B has reached up, because the shaft is continuously rotating, so each of the points they would be shifted. So when B reaches the topmost layer, now B would be subjected to compression and A would be subjected to tension. So this is called as reversed or cyclic stresses, where a particular member, or we can say a particular point, is subjected to two kinds of stresses in the same cycle. So here I can say that since I have written for point A and B, I'll say that a stress which changes its nature when passing from one point to another is called as cyclic stress. So here I have written a stress which is changing its nature. Nature means at first point A was subjected to compression. When the shaft has rotated, now point A is subjected to tension. So the nature has changed. Top layer first it was at point A, then the top layer is at point B. So at first A was subjected to compression, next A was subjected to tension. So the nature of stress has changed. So from one point to another, it is called as cyclic stress. Now once we understood what is cyclic stress, then we can easily go for fatigue failure. So here I will write down after cyclic stress, fatigue failure. Now in fatigue failure, as we have seen in cyclic stress, the stress changes its nature. Similarly in fatigue failure, the load which is acting, it will change its direction and it will change its value. That is, the same machine member will be subjected to different values of load and in different directions. So it is somewhat similar to reversed or cyclic stress. So fatigue failure, it is a kind of failure in which the load changes its magnitude and direction continuously. Next, in fatigue failure, the component or machine part is subjected to variable stresses over a long period of time. As I have written here, in fatigue failure, the component or a product or a machine part we have, it is subjected to variable stresses, means the stresses, they continuously go on changing their value, and it is subjected to these stresses for a prolonged period, for a continuous period, or we can say over a long time. So fatigue failure is mostly seen in those components or products which are used over time, that is, which are used for number of years, and they are subjected to variable stresses, and finally they would be failing under the fatigue load. So here I'll say that because of fatigue, residual stresses are set up in a machine part or a component. Next, see, when in case of fatigue failure, the object or a product or machine part, it is subjected to various types of stresses, various values of stresses over long period of time, that is for number of years. Then what happens, some stresses which are residual, they get stored in that material, and over time, if sudden value or some value of load is acting on that machine part, it may develop inside cracks, and that cracks, once it reaches inside the surface, then it will be propagating, it will move towards the surface from inside to outside, and finally the object would be breaking. So here I can write down that when internal cracks are developed, then the object or a product, or we can say machine part, may fail anytime. That is, even a small value of load is necessary, or a very small value of load can break that machine part, because through the number of years, for a long period, it was subjected to number of stresses which were changing their direction as well as their value. Because of that, fatigue is developed inside the material, and when a small load reaches that object, it results in internal cracks, and then the failure of the material starts. So I can give the examples of machine members subjected to fatigue failure. See, fatigue failure is more prominent in those machines which are used over a number of periods. So I can give the examples, like we can say IC engines, that is internal combustion engines. As we know, they continuously operate at high temperatures for a long period of time, then they would be failing because of fatigue, and that too, the failure will be around, we can say, from 15 to 20 years. That is, after 15 to 20 years, these IC engines, they will be failing because of fatigue. Next, steam turbines. Steam turbines are also subjected to fatigue loading. Next, we can say furnaces. They are also subjected to fatigue loading. And finally, I can give you the example of cranes or hooks. They are also the example of fatigue loading members. So here in this video, we have seen that what is meant by fatigue failure with its detailed explanation, starting with reversed or cyclic stresses.